Well, now I'd like to turn to another fantastic modeler, Seth Newman. Seth's the owner of Model Railroad Control Systems, MRCS. I met Seth through George Bunza, and I was so impressed with what he does and the models that he builds and the company that he runs. I couldn't resist having him on the show tonight. So Seth, thank you so much for being here. I really do appreciate it.
Well, thank you. Let me see if I can share here.
Okay.
And all right.
And Seth, I know that you've got a conflict tonight too, so I understand you've got to go early. So
Yeah.
I'd like to. There's so many things I'd like to talk to you about. You've got a beautiful layout, I understand, that's operational and oriented, and I'd really like to talk to you about a lot of different subjects, but I just don't have time tonight with your schedule and with the length of the show.
Well, there's so much good stuff to do and so much great modeling and wonderful things people are doing. So let me just see here. I'm trying to find my, well, that's weird. Okay, here it is. This worked the other day at the sound check, and now I am not seeing my, let me just kill a few windows here and we'll, oh, come on. Nobody wants to go away without, just did you check this thing? So let's get back here to, all right, well, I don't know where it has gone. Let me, maybe if I go full screen, this will work a little better. What I was going to do is give you here, show all windows. So why? Where's it gone? Bear with me 1 second here. Let me release the share and start again. Screen share. No. 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 All right. All right, let's try this. Oh, it's probably down here. Well, that's odd. All right. You would not realize I had been in marketing for some time when I cannot get my PowerPoint to come up. So let's see here. Yeah, we've got maybe 40 minutes, so I'll try and take this quickly. Model Railroad Control Systems, a business I founded with my late business partner, Chuck Catania, in, I think, 2014. And we were doing a lot of electronics projects for people, primarily in the Bay Area, but as time went on, over a wider and wider area. They were primarily CMRI, centralized traffic control systems, and Chuck had been doing a whole bunch of interesting things with train order boards, train order systems, things to support timetable and train order operations. And I had been kind of leveraging my background in telecom to do telephone systems for operating railroads. So anyway, we were doing several projects and having some frustrations with some of the available products, and the thing that really got us going was an attempt to implement the CMRI protocol on Arduino. And a number of people had done this, but nobody had ever productized it. And so we decided we would do that because we were having, I wouldn't say difficulty, but it just always seemed to work out that the configuration of existing CMRI boards that Dr. Chubb had designed never quite came out very well in terms of I/O for what we needed. So we would have systems that would use an S Mini that typically would have 24 inputs and 48 outputs, and we'd end up needing 25 inputs and only 12 outputs and things like that. So the idea of the Arduino was we could control the input-output configuration ourselves and get a much better fit and also a much lower cost entry point into the basic node. Anyway, so that's a little bit of our origin story. What are we about? Basically putting cool electronics in people's hands. Let's see here. I am going to. A lot of this is open source. So, in general, if you go to our site and you see a design you like, schematics, CAD designs are available. You're free to download it, recompile it, change the software, change the configuration of the parts, go have them built at any board house you like. But we also sell bare boards and assembled and tested boards. We do custom work, or at this point, I do custom work. And we're just happy to put cool stuff out there. A great deal of it is modelers who are very creative and want to build interesting electronics. They're happy to share, but they do not want to get in the business of distribution. So we've got the platform running, and we can handle that, and we take care of assembling things, keeping them in stock. We have a website that you can order from anytime you want. Generally, the high runners are in stock. The other stuff will build in a few weeks. So, if you just like to design stuff and don't want to build it, and certainly don't want to be in the business of it, we're there. And I'm always interested in recruiting more contributors. Our business model is to keep the margins very low, just enough to cover the real costs of running a business, and they're there. Nobody's trying to rip you off in this business. As you've all heard, the way to make a small fortune in model railroading is to start with a large one. I also do handle some commercial products, particularly in the telephone product line, simply because the people who sell things like handsets and ringing generators and so forth aren't really equipped to deal with individuals who aren't entirely sure what they need. So, I buy those in bulk and, resell them. And then here's the list of our main product lines. And there's some other stuff. So, but the main things I think are the CMRI based Arduino nodes, telephone systems, switch motors, drivers, and mounts. We do some interesting things with simple signals. The train order business, or train order boards and semaphore controllers, approach indicators. We're doing a lot more with that. I've got a contributor now who's really interested in that and does some work on railroads that are doing those things, and has contributed some very nice designs. And then we do community and club projects. I've done several projects with Pacific Coast Region, Coast Division, with Phil Edholm. We do some club projects. There's one hanging out there with Phil's club, and we also have some miscellaneous things like a Wi-Fi fast clock, which is very handy little fast clock system that the software, the server is free, and you can run it on your iPhone or any smartphone or tablet. So we also sell, physical displays, but you can do this with hardware you've already got. So this is a little bit of an updated program I did for the Rails by the Bay convention last summer that Phil and I did a lot of work on. Our cpNode, which is our Arduino-based Chub node, we've moved to the Pro Mini Arduino from the original one we were using, mostly because it became unavailable, but it turned out to be also a nice thing where the cost curves were favoring using the Pro Mini, and we were able to hold the line on price in the face of global increases in electronics prices that I'm sure you've all heard about, especially if you tried to buy a car recently. We also provided a Pro Mini replacement for the BB Leo, the old processor. So if you've got an old processor and need to replace old board and need to replace the processor, well, we've got an alternative for you. We've improved or we've made an improved motherboard for our cpOD occupancy detectors. It's higher density and hence a little lower cost. And I'll tap these things a little bit. Andrew Deek has contributed an Arduino Mega base node. We call it a Mega node. And that will get you to, I think, 188 lines. So we provide a group of different nodes in various capacities with various features that you can use as you need to, equip your layout control bus. And just last year, we've had an explosion of wiring adapters for both traditional and Arduino-based CMRI boards. And by the way, you can mix these. If you have classic Chubb-style CMRI nodes, why you can add the various Arduino ones and mix and match them in a network, and it works just fine. And then a couple of other features. So let's look real quickly. This is the classic cpNode, which is again the Arduino-based CMRI node, and you can see the big square goodie in the bottom. Can you see my cursor here?
Yes.
Okay, so this board replaces the original BB Leo, and the point is, if you've got the old stuff, you're not stuck. We have a board that will plug right in and provide compatibility. And that's really the big message. And that board looks like this. You can see it's not very big. And then here's one which is just a native cpNode or a Pro Mini node, and you can just plug the Pro Mini directly in. And again, there's less components. It saves you some cost. And if you're building them yourselves, you have great, flexibility to just not stuff the stuff you don't want. So the cost can be very competitive. The expanded motherboard, as you can see, we have 8 detector positions per board, and you can stack 2 of them together. They just snap together with a standard Molex connector. So, if you're trying to detect an area where you'll have a lot of trackage, like an interlocking, these are great because you can get a lot of density in here and mount your detectors to the motherboard. And that's very much the same approach that Dr. Chubb used with his ODMB and DCCOD. And these detectors are compatible with the DCCOD. The only thing is the DCCOD won't fit into this motherboard because ours are a little narrower and smaller. And to get the density that the customers who requested this wanted, we had to tighten up the spacing. So you can't use the DCCOD. We do have an ODX4 that will work with either of them. And again, you can mix and match. So, we try very hard to maintain compatibility and, not obsolete your investment. And, frankly, to make it easier for you to recycle stuff. It often happens in the hobby that people downsize or they change interests, and perfectly usable electronics become available. And gee, isn't it great when we can, help somebody recover some of their investment, get a good price ourselves, and keep perfectly usable stuff running. And then, I mentioned the Mega Node. This is Andrew's board, and what this does is you actually plug this onto a Arduino Mega, which is a 56 line guy, and then he's got expansion. You can use our existing I2C expanders. So there's a whole lot of ways to build this out to as many lines as you want. And really the idea of using, or one of the drivers of using the Arduino based CMRI nodes, is that you can have smaller but affordable nodes located closer to the signals and switches and so forth they're supposed to control, and that makes the installation much easier to do and much easier to troubleshoot. And then piles of adapters, and rather than take our limited time and explain all the various flavors of these, they're certainly listed on our website, modelrailroadcontrolsystems.com, but contact me, sales@modelrailroadcontrolsystems.com, and explain what you want to do. And we probably have one that works, and if not, we'll modify it and make yet another. I got to say, I've never built one of these that didn't end up being used somewhere sometime. So I certainly don't mind making more. Here's a little project. It's actually not on the site yet. I was hoping to have this done last summer, and as you can see, it was overcome by events. But this is a little, very simple optical detector. It operates in several configurations, and I sell them in panels of 3 for $5. And I would say, if you're somebody who likes to do electronics and fools around with optical detectors, get a couple of these and just keep them in your toolbox. You just snap one apart, stuff it up to do what you want to do, and it's like the Swiss Army knife of optical detector kits. And it can also be used as a really simple 2-line version of Dr. Chubb's SMC12 Tortoise driver. So, I mean, it slices, it dices, it cuts, it whatever. But handy little tool. And again, it was Don Wood, who we unfortunately lost over the pandemic. I don't think we lost him to COVID, thankfully, but Don had described this circuit, and it was kind of a staple in the CMRI community for years. So I just decided to make a board where you could do it easily. Okay, so the next major area of model railroad control systems is telephones. And oh, thanks. Just thought I had some chats I needed to answer. A lot of these are boards I developed, as I was doing phone systems for people. So this is a handy little one that, if you don't want to get into telephone style punch blocks, or have a whole lot of barrier strips around to distribute your telephone wiring, you just plug this board on one of these modular connectors on the right into our telephone line board. And it distributes as many as 12 lines, the 2 sides of the phone line, which are traditionally called tip and ring. And it also takes the system power supply and generates any auxiliary voltage you like with this little bucking converter. Normally it's 12 volts, so that's what I put on the board. And again, now you have a little power distributor, and you can either feed it locally with a wall wart, a 24-volt wall wart, or you can piggyback off the little bus that runs on a 6-wire module from many of my other telephone boards. So anyway, handy little tool if you're building a phone system. I think if you want to build one, the best thing to do is email me or call me, and we'll walk through your requirements, and I'll give you a list of what I think you need. And you can use my stuff, or you can do it, whatever way's comfortable for you. You might have a warehouse full of old Jones barrier strips for all I know, and that may be the best solution for you. And let's see here. Next. One thing that I discovered over time was I had developed some circuits that repurposed some of the contacts in the traditional telephones we all grew up with, typically the Western Electric 500 type telephone set. And it turns out that some fairly nice reproduction phones that are in many cases a good choice for the layout room don't have that extra contact. Or maybe you're using period equipment, which very often didn't have the post-war standard configuration of contacts. So here's a board where you essentially feed the phone line in one side on the left and bring it out on the right, and we have modular and screw terminals. You don't need to stuff all this stuff if you're not using those options, but there's nothing to stop you from coming in on a modular jack and a modular phone line and coming out on wires. And what happens is when that phone goes off hook, the little relay in the blue on the left there will fire, and you get a contact and do whatever you need to do. So it's very handy for a lot of these control circuits. And sorry about my phone system ringing there, but we're not going to pay attention to him. Another circuit that I've written about a lot, and it was in the OPSIG Compendium of Operations, Chapter 9, are latches that when a station has been called, you'd like to leave a light lit until the phone is picked up. So, boy, this one's persistent, huh? So say you've called the yard master, and he's busy with something else at the other end of the yard. He's yarding a big train, but you don't want him to forget that you called him. So this circuit allows you to light a little LED or something similar, so that when he comes back to his desk, he can see that the light's lit and call your dispatcher back and find out what needs to happen. So this is real simple. The whole board here is about 2 inches by 1.5 inches. And I can't tell you how much time I had published a schematic of this using, just standard commercial relays, and people constantly calling up going, I don't quite get how this works, or why does that diode need to be there? So finally, the easiest answer was to just make a board that had all this stuff on it, and you just wire up to it. And let's see. This one's a little more obscure, but it's something new I just came out with a month or two ago. A friend of mine in Utah had been kind of switching back and forth with different kinds of dispatcher arrangements, and has a mostly electronic system, but he decided he liked the look of the old carbon mic, an old telephone style mic, which, is very different electrically than most of the other mics we use today. And so the idea here is you wire your mic into this, you give it regulated 12 volts, and it gives you isolated and balanced audio that you can feed into anything else. So this is very nice, particularly where you need microphone and amplified speaker kind of arrangements, and you need to be able to control the gain and the microphone side of, and you want to use one of these vintage microphones. And let's see here. So we do a lot of work, obviously in interfacing with various types of turnout controls. And this is way back while Chuck was still alive. We had a very nice gentleman over in the East Bay who must have been hoarding all these old NJ International and Ken Kidder and similar switch machines, and they needed these humongous capacitive discharge supplies, and they would shake themselves apart. And he wanted to use this with a little tower controller, for staging routes on his staging throat. And of course, they tended to shake themselves apart, and they were causing electrical interference to get into everything else in his layout. So what I did is built something using this little, what's called a one-shot, which is you throw the switch or you change the input, and it generates a single pulse, and you can set the length of the pulse in this seconds, long enough to throw the machine, but not long enough to heat up the coil and burn it out. And Mark Gurries was kind enough to get involved and do a little electrical modeling to give us a nice smooth waveform that was sharp enough to trigger the twin coil machine, but mild enough to not cause it to slam into the points and eventually break the throw bar, and also controlled the electrical interference. So it's a nice little board for probably a pretty rare case, but if you find that you need to put electronic controls on an ancient twin coil switch machine, it's very handy to have. Then we've also had these the other extreme, very modern switch machine we carry is the MP1 and MP5 by MTB Electronics in the Czech Republic. And these are very nice. They're tiny. They're roughly the cross section, the square footprint of a tortoise, but they're only 3/4 of an inch deep. So they're great for modules and upper decks and any place where vertical clearance is an issue. And the importer is a good friend of mine, Richard Brennan. If you were on very early, we were talking about one of his other projects. And so we've got these nice laser cut adapter plates, and those are really nice. And let's see. We had a product in the past, and I don't know if anybody here is an existing user of the MP motors and this controller I had, but this is a DCC controller. So just imagine an 8 switch machine stationary decoder. They exist for all sorts of motors from various people, but there was none for the MPD8. Anyway, we were buying one from another vendor, good guy, and it was based on an old twin coil decoder he had. For various reasons, mostly the parts involved had become unobtainable, and this was even before our more recent supply travails. And ultimately, I found a European vendor who was familiar with MTB and had built a board to control their switch machines. And so I was able to license the design, and I should, at some point in the not too distant future, have a version of that board. There were some issues with the original board, and it didn't work well with my production process. So I needed to change the layout. So that's what I'm working on. Anyway, nice little board. Does the job, controls up to 8 machines. You can set it to any address in the DCC accessory range. And let's see. This is just a cute little variation on one of those CMRI adapters. You can see John Plocker with his Cal Graduate School Go Bear stuff. He just did that to tweak me because I went to the other school. But as you can see, this thing pops onto a Tortoise, and You can insert resistors if you want into any of the leads that you might be using to control ground lights. And it's got an RJ45 on the back. So RJ45 cabling is a really nice way to control wiring hygiene under your layout. And, you know, Phil's a big advocate of this also. So maybe one of these days we'll do our little clinic on that. Sorry, talking fast, drying out my mouth. As I said, there's a number of boards that I use just because they're convenient for me when I'm assembling projects for people. This one is a power distribution board. You can see on the left there's a little barrel connector. So one option is to just plug any power supply you like into it that's got one of those 2.1 millimeter barrel connectors, and you can stuff this thing. This one's got 8 lines of power and 8 of ground, but they could be as many as 12 or, whatever size terminal block you want to stuff in. You can also feed it with the screw terminal, and you have the option of sticking one of these little bucking converters in. So, whatever your auxiliary power bus on your layout is, let's say you need some 5 volts to power some Arduinos, you might just clip off your 12-volt bus, come into the board on the little blue terminal connector and adjust your power supply to 5 volts. And now you've got 5 volts and you can run some clever animation. So it's useful for all sorts of stuff like that. This one I don't have a picture of. But the idea here is if you want a spring switch simulator. So you'll have a couple of optical simulators. The train comes up to the leaving switch on a siding, and the optical detector is fired. The circuit throws the motor so you can get out, and then waits till the detectors are cleared, runs a little bit of time, and then returns it. And you can put these at either end, and you can have, essentially a siding with a spring switch, very common in ore and mining, all kinds of mining applications where you wanted long ore trains to be able to pass one another. Some railroads, SP, for example, had a lot of places where their sidings were spring switch one end, CTC the other. So there's a lot of tricks that railroads used when there were well-defined traffic patterns and they wanted to save a little money. And you can simulate it. Train order boards. This is a real cute thing we introduced last year, and it's proving to be a fairly steady seller. It's a Semaphore controller based on 2 servos, and as you can see, there's red, green, and yellow lines, and a pot for setting your red, yellow, and green position. So you just hook your Semaphore up to these the horns on the servo, and do the adjustment, and then you can bring your control lines in up on the little green terminal block on the left. I provide push buttons so that you can force the various lines when you're setting them up, but they're never actually used in operation. So this is as I say, been very nice. And the way the thing is designed, you can just mount it with a couple of angle brackets. We've been Earl Gerbavon, who's the other name there, does a lot of 3D printing, and we'll probably eventually make a 3D bracket for this. So you just snap the thing into the bracket, mount it under the train order board or a pair of ABS Semaphore signals, and you're in business. This is a very simple train order controller. It's just a bunch of toggle switches. I do have some rotary switches to make one that looks a little bit more like a US&S control knob, but this is real easy and nice alternative to cutting a bunch of holes and mounting toggle switches in your fascia. This one is a really cute thing that John John Schmidt did. And John was working with me on the servo controller, the Semaphore controller. And what this situation is, if you have a train order operator on a timetable and train order layout, it often happens that, he's not in a position to see approaching trains. But in the real world, there would typically be an approach circuit and it would ring a bell and the operator would know that a train was coming and it was time to check with the dispatcher and find out if there were orders coming. Some railroads like the SP left their order boards at red, and the train order operator would have to call and say, I have a train coming east, and then the dispatcher would say if he had any more orders for him. But the issue is you needed to know in advance because you didn't want the train to have to stop when there was no order, because then they'd waste all this time stopping and starting up again, and depending on the grade and the length of the train, risk pulling a drawbar, so they didn't really want to do that. Anyway, so this is a nice little solution based on an Arduino Nano, as you can see. And let's see here. If you've got an existing CTC board, and actually I got some interesting things there. I do have a client who is looking to sell a 30-column US&S machine, so contact me if you're interested. But I did, for a project for the California State Railroad Museum, an animation of Tony Custer's CTC machine from the Allegheny Midland, and the standard incandescent lights were not bright enough to be seen in the room. So we found a source for LED replacements, and they're much brighter, and also turns out they're much easier for people who are color challenged to see. So that's a neat little thing I stock. Oh, and then we do community designs, which is really the life of the whole thing, because I certainly couldn't, keep the pipeline full of what people want. But, you can see we have these very inexpensive little signal heads. You buy them in panels of 12. They're great if you just want to see if signaling's for you. If you're building a layout and you really don't want to invest $30 or $40 each in, model quality signals, but you do want to get running, or maybe you want to get running knowing you still have scenery to do and you don't want to wreck the $30 or $40 model quality signals. So these are wonderful. Again, they've been very popular. Morse code buzzer controller. This is usually used with phone systems. One thing we found is that in having buzzers and bells at the phones, there was a tendency for the room to get pretty loud with, all the buzzers buzzing and sounding the same, or all the ringers ringing and echoing around the basement. So what this does is it gives up to 7 stations a unique call sign, and it's actually tapped out in Railroad Morse. We try to use the original call signs if we can find them, and it's a prototype layout. And it'll only play one at a time, and each one's unique. And everybody said, oh, this won't possibly work because nobody knows Railroad Morse. But it actually turns out that you will learn your cadence by your second call. And now people know which one it is. We're not trying to locate these sounds echoing around the basement, and calls get answered quickly and works beautifully. Let's see here. There was one I wanted to show you. This is an example of actually one of Jeff Bunz's boards. This is a little twin T detector. Jeff, as you all know, writes this wonderful column in MRH and has lots of projects. I generally pick up his boards and will make them available, usually in panels of however many fit in a 4-inch by 4-inch panel. And those are like $5 each. If there's a Jeff project you like and I don't catalog it, send me a message. I'll almost certainly be able to make them for you. And that's an alternative to going off and having your own boards made, which, as Jeff says, it's not that difficult, but every vendor has their own design rules and their own process, and they're all a little different. So if you just need one or two and don't want to be bothered, come to me. We make our little DCC flagman in a couple of sizes, and this looks like an error in my screen capture. And then this is a new Jeff board that was brand new last summer. This is essentially, you put this on your DCC line and it gives you a logic level out, and then you can use anybody's Arduino code. Jeff's written some fantastic examples to build your own essentially smart decoder. So club projects. This is one we did for PCR for the Coast Division. During the pandemic, Phil really kept us going by having these Saturday morning meetings. A lot of people wanted to do keep alives, energy storage devices. So this is a quick and dirty super cap energy storage device. It will fit in any MD shell and HO. And I sell them as bare boards or as kits. Again, that's been something that been a fairly steady demand for. Oh, so here's Jeff again, and there's one or two that I didn't mention. And that's really the thing. Don't see what you want, ask. Have something that you don't see and think people might be interested in, call and tell me about it. So anyway.
Well, I tell you, Seth, I was really impressed. And mostly I was impressed with how you're willing to work with modelers to help all of us be able to take electronics and include it in our modeling.